Hello, Jai Hind, and good evening, everyone. So, in today's session, we will be doing something different. We will be starting with a new chapter 20, class 10 math. So, without wasting further time, let us dive into the topic. Suppose if I want to find the distances between two ships, height of a building, minar, etc., we use heights and distance concept of heights and distances of trigonometry. So, trigonometric ratios of standard angles. We have to memorize that table to solve problems in this chapter. Let me show you the let me show you the table. Please memorize this table. I hope you guys have memorized this table. Now let us begin by defining some basic in this chapter. First one is the line of sight. So what is this line of sight? Line of sight is basically the eye of observer to the point in the object is known as a line of sight. I repeat again, it is an imaginary line drawn from the eye of an observer to the point sight. Second definition, angle of elevation. So angle of elevation is the angle formed between a line of sight and horizontal. Angle of depression is also the same, and horizontal is called angle of depression. Now that we know about these three terms, let us begin to solve problems. Here we go, our first problem. The length of the times its height. Find the angle of elevation of the sun. So very simple sum. Let us start solving it. So it's first we have to assume the height of the vertical tower to be x meters. Let the height of vertical tower equal to x meters. And then we have to also assume the length of shadow is equal to root 3 times x meter. So in this case, we have to find the angle of elevation. So first we have to draw a most important thing in heights and distances is that your diagram should be proper and perfect, or else you will tend to lose marks in this. This is just a rough diagram, so please. So we learned that length of the height of tower is x meters. This is root 3x and this one is x. So we have given perpendicular. They have given us perpendicular and they have given us base. So by tan theta we can figure out the angle of elevation. So tan theta equal to perpendicular by base, that is x by root 3 times x. Times x, that is equal to 1 upon root 3. So we know tan theta, now we got the value as tan theta equal to 1 upon root 3. So we know 1 upon root 3 is tan 30. Therefore, theta equal to 30 degrees. 30 degrees. Therefore, the angle of elevation of sun is 30 degrees. So is it clear, everyone? Okay, fine. If it's clear to everyone, please press one like button. Next, we'll go to the next problem. Similar, same set. It is exactly similar to what we solved right now. Okay, so once, just give me a minute. Just clear everything. So next sum is also a similar problem. So it says height of a tree. So he has given the height of tree to be root 3 x. So first we have to assume that length of the shadow is root x meters. So let's let the length of shadow equal to x meters, and therefore the height of tree is equal to root 3 times x meter. So we know height of tree, and they've given it as root 3. So length you have to multiply to find the height. Now we can use tan theta to find the value of angle of elevation. So before that, let us draw our diagram. Pillar is given as root 3x, and this base is given as x meter. So they have given perpendicular and they have given us base. So by tan theta equal to perpendicular by base, which is nothing but perpendicular is root 3x by x, which is nothing but root 3. Now we've got value of tan theta to be root 3. So if we go back, root 3 comes under tan 60. So we can say that theta is equal to 60 degrees. Therefore, the angle of elevation is 60 degrees. Clear? Now let us look at another problem. Okay, I will read the problem out. See, a ladder is placed along a wall such that its upper end is resting against the vertical wall. The foot of the ladder from the wall is 2.4 meters from the wall, which makes an angle of 68 degrees with the ground. Find up to which the ladder reaches. So this up to which the length, find up to which length of, sorry, find up to which the ladder reaches is the question mark. So he has given us a scenario where there is a ladder. I hope everyone have seen what a ladder is. So there's a ladder and it is resting again. So this is the ladder here, and it is resting against a wall. So the foot of the ladder here to here, the distance here is 2.4 meters from the wall and makes an angle of 68 degrees with the ground. So angle of elevation is given to be 68 degrees. So let us assume that the first let the height of up to sorry which the ladder reaches is equal to x meter. So now given angle AOE equal to angle AOE. This angle AOE equal to 68 degrees. So applying, we know they have given us the value of perpendicular and base. Perpendicular we have already determined to be x meters. So x or h meters or in h5. So tan, by applying tan theta equal to perpendicular by base, we get um, perpendicular by base is nothing but your 2.4 meters. Next step is going to be tan theta is nothing but tan 28. We figured it out. Tan 28, 68 equal to perpendicular by 2.4. So there is no value as that there is in our root table there is in this trigonometric ratios of standard angles there is no value for say tan 68. So um, now the value in your last page of your book in Selena, there is a root table called tangents. In there, value of tan 68 is given to be 2.475 into perpendicular by 2.4. To find perpendicular now, it is very simple. Just multiply perpendicular equal to uh, 2.475 into 2.4. You will get the value as 5.94 meters. Now let us try another example from your textbook. This is an exercise question. Now till now whatever we were doing was related to exercise questions. This is the last exercise question I will be doing. Next, we'll be doing some board questions. So now a kite is attached to a string. So there is one big string here, and there's a kite attached to the string. The, there's a kite which is attached to the string. You have to figure out the length of string, your rope. When the height of the kite is around 60 meters. So this the height is around 60 meters. So 60 meter, and it makes an angle of elevation of 30 degrees with the ground. So ground distance they have not given anything. So let us assume it to be again x. And the length of first it is let's see. Sorry guys, back. Find the distance. So let length of rope be x meters. Now perpendicular and they've given the perpendicular by hypotenuse. Now we have to figure it out. So sine 30 now. We can use sine 30, sine theta equal to perpendicular by hypotenuse. So we get sine 30 equal to 60 by x. Sine 30 is nothing but 1 by 2 equal to 60 by x. So just cross multiply this, you will get x equal to 62 is a 120, which is the answer. Therefore, the length of rope is 120 meters. So till here, I hope you guys have understood how to solve problems like this. Now we will be starting with one question which is important. This is a word question. Now, he has given a man observes the angle of elevation from a top of tower to be 45 meters. So there is a tower. Sorry, guys. So there is one tower here, and the question says a man observes the angle of elevation from a top of tower be 45 degrees. So this is the tower here. It's tower. This is the tower, and so let us name this tower A, B, C, and D. On moving, so initial point of the man is here. Now he moves 20 meters close. He moves a distance of 20 meters closer to the tower, and angle of elevation from at initial point, angle of elevation was found to be 45 degrees. Now it has changed to 60 degrees. So now he is asking you to find the height of this tower, and it should be correct to two significant figures. So how do we solve this sum? Let us solve it together. No, there's a tower. Now, as we, in all cases we were assuming things, here also we have to assume. So first let AB be the length of tower, and into shape tower, sorry guys, and C and D be 2 points, two positions of the man. I know what to find. Stop. Now CD, what? So CD was 20 meters, found to be 20 meters. He moved 20 meters close from it was at point C, and he moved to when the angle of elevation was 45 degrees. So now he moves by 20 meters closer to the tower, and his angle of elevation changes to 60 degrees. So angle ACB equal to 45 degrees, 45 degrees, and angle ADB be equal to 60 degrees. And this was the information given to us. Now, in this case, there's not one triangle to deal with. We have two triangles to deal with. So how do we do that? So first, we have to consider one of the triangles, solve the triangle, then come to the other, solve and then figure the value out. So let us see how it is done. Let me erase this for you. The space constraint. Now, first thing we have to consider was that triangle ACB. ACB is that whole triangle in which the initial position of man was and initial angle of elevation was found to be 45. So we have to consider that triangle. So in triangle, sorry guys, I'll re-explain the sum to you guys. One second. My bad. Yes. This is a board question. So let us see how we can analyze this question. So there's a man, a man observes the angle of elevation of a top of the tower to be 45 degrees. So there is a man, let us use this space. There's a man, there's a tower here, and he he sees the there's a tower here, and the man sees the top of the tower, and the angle of the angle of elevation is found to be 45 degrees. And now this is D, this is C, B, and A. Now he moves 20 meters closer. So first, when initially his angle of elevation was 45 degrees. Now he's moving 20 meters nearer to the tower, closer to the tower, and his angle of elevation changes to 60 degrees. So his angle of elevation now will be 60 degrees. Clear? Now we have to find the height of tower and uh, we have to give this height of tower correct to two significant figures. Let us see how this problem is solved. So first one, let us assume let AB be the tower and C and D be the positions of the man. Now CD equal to 20 meters, angle ACB equal to 45 degrees, and angle ADB equal to 60 degrees. We figured it out. See, angle ADB is equal to 45 and angle ACB is equal to 60 degrees. We figured it out. Now we have to now there's not one triangle we have to deal with. So there are multiple two triangles to deal with. So first we take a main triangle to deal with. So the main triangle is ADB. angle ACB. No, this is C, this is D. So angle ACB, we have to take the triangle ACB, evaluate the answer. Next, come to angle ADB. It's a triangle ADB. Find out the value and then further evaluate. I'll show you how it is done. So first one, we have to write in triangle ACB, tan 45 equal to perpendicular by base. Why did I take tan theta? So they have given us the base value and the perpendicular value of x, and base is 20 plus x or something. So it will be easier to calculate. So tan 45 is 1. 1 equal to perpendicular divided by base is nothing but CD plus CB, or no, CD plus DB, this 20 plus this remaining distance, CD plus DB. Perpendicular 1 equal to perpendicular CD, we know is it as 20 meters, 20 plus DB. Now using this value, this one. Okay, now 1 equal to, so we have to figure out P. P equal to 20 minus 20 plus BD, BD or BD equal to P minus 20 or P minus 20. So first equation we figured it out. Guess we are going to require another slide. Yes. So we found out AB value, so no, BD value we found. Now we have to substitute BD value in triangle ADB. So where is triangle ABD? ABD, this 60-degree triangle. ADB, we have to substitute the value to figure the answer out. So tan 60 in triangle ADB, tan 60 equal to perpendicular by base. Base was BD for us. Now BD, perpendicular by base, BD, base. So base was BD. So where tan 60 is root 3 equal to perpendicular by base was 20, perpendicular minus 20, using equation 1. So now root 3p minus 20 root 3 equal to perpendicular, or AB, this base, sorry. No, perpendicular. So we have to find out. So we push this 20 this side. So root 3 p minus p equal to 20 root 3. So I take p common. Root 3 minus 1 equal to 20 root 3. And that. So now AB, which was perpendicular, equal to 20 root 3, 20 root 3 divided by root 3 minus 1, root 3 minus 1. So this is nothing but 20 into 1.732 divided by 1.732 minus 1, which is nothing but 34.6 divided by 0.73, which gives us the value of 47.39. Therefore, the this the height of tower is 47.39 meters. Let Now I hope we have understood the sum clearly, and now let us move to the next question. Just finish. This is also a board question. So it says the angle of elevation from a point P of a tower is 50 meters high, of tower 50 meters high is 60 degrees, and that of tower PT is from point Q is 30 degrees. So find of the height of PT correct to the nearest meter. So he has given the angle of elevation of a tower, a bigger tower called QR, to be 50 meters. So the height of QR tower is 50 meters, and that small tower, they also that small tower PT is there. Um, and it's from point Q is the angle of elevation is 30 degrees. So it's just asking you to find the height of tower correct to nearest meter. So I will give you 1 minute, 2 minutes to solve this problem. Guys, if you have found the answer, please post them down below in the comment section, please. Guys, 1 more minute, please hurry up. Okay, the time's up. So let me solve this problem for you guys. So the angle of elevation from a point of tower is 50 meters high and 60 degrees, and that of tower PT from a point Q is 30 degrees. Find the height of tower PT correct to nearest meter. So very straightforward ICSE question. There are two towers, as we can extract from that this question. There are two towers, one tower like this one tower, and there's one Chotu tower from here, from here. This is the bigger tower, and this is the smaller tower. And Q, no, this is R, this is Q, this is P, this point here P, and this is T. Angle of elevation here is 60 degrees, and here is 30 degrees. First, we have to consider the big triangle RPQ. This big triangle we have to consider. In triangle RPQ, tan 60. So they have given the angle of elevation of RQ tower mid is to be 60 degrees. So we have to use tan here. Tan 60 equal to perpendicular by base. Perpendicular QR is given as 50 meters. Perpendicular by base. So tan 60 is √3 equal to perpendicular by 50. No, 50 by perpendicular base. Sorry, guys. My bad. 50 divided by B. So B equal to 50 divided by √3. First equation we got. Now we have to consider another triangle. TPQ. This TPQ, this triangle. TPQ, this triangle. This angle of elevation is given as 30 degrees. So now in triangle TPQ, tan theta is equal to perpendicular by base. So base they have not given tan 30. So tan theta here is tan 30 is equal to perpendicular by base. So tan 30 is 1 by √3. Now we have to substitute the value of perpendicular and base. So perpendicular is P divided by 50 divided by √3. So √3P is equal 1 by √3. 1 by √3 equal to P into √3 divided by 50. TP equal to, or perpendicular, sorry, please. Perpendicular equal to 50 divided by √3 into √3. So here we have to rationalize the denominators, or else the calculation will become much harder to solve. So 50 divided by √3 into √3 is 3. So the value of perpendicular is equal to 16.66. But in the question, you cannot leave it as 16.66 meters at all. Here they have given, you have to find the height of tower PT correct to the nearest meter. So which is the nearest meter to 16.66? Yes, absolutely right. It is 17 meters. So 17 meters for the height of, well, tower PR. PT is 17 meters. I hope you have understood this sum. This is the last board sum which we'll be solving. Then we'll have a little bit of numericals and then we will close on the chapter. Now, last one. So, an aeroplane at an altitude 1,500 meters finds two ships sailing towards it in the same direction. Full stop. The angle of depression are 45 and 30 respectively. Find the distance between the two ships. So he has told that there is an aeroplane which is flying at an altitude 1,500 meters, and it sees two ships sailing towards it. So if this is the aeroplane and there is two ships sailing towards the aeroplane, and this is um, 1 second. This is the aeroplane. So one ship it finds here, and another ship it finds here. And now angle of 30 and 45 respectively. And we have to figure out the distance between two ships. All the while now we were solving problems on height, but we never solved problems on distance. So this one is based on distance. Teach you this, then after some numericals there will be a um, bonus board question for you guys to solve. There's an aeroplane and it finds two ships sailing towards it. So one ship here and one ship from here. Sorry, guys. From here it figures, it says. So first, this is 0 degrees. Here 45 and the angle close to the big triangle is 30 degrees, and they have named it as BDC A B C D A B C D. Let now we have to assume something. Let D be the aeroplane. And A and B are two ships. So A and B are two ships. Now they have given the value of CD to be 1,500 meters, 1500 meters. So CD equal to 1500 meters. Angle EDA, this 0 degrees is EDA. This EDA and EDB. Angle EDA is equal to 45 and angle EDB equal to 30 degrees. Now from the information we can solve this problem, not an issue. So there is first one in big triangle here, no, DBC. So DBC in this triangle, so this DBC. So tan 45 triangle DBC BC tan 45 is equal to D perpendicular by base. Base is unknown, so perpendicular 1500 by B equal to tan 45. So tan 45 is 1 equal to 1500 divided by base. Base equal to 150 BC, or base equal to 1500 meters. So first equation. Next, figure out about triangle ADC. DC is equal to, in triangle ADC, tan 30 equal to DC divided by AB. So DC is perpendicular divided by base. That is 1 by root 3. Tan 30, as we know, is 1 by root 3 divided by perpendicular. We figured it out to be 1500 plus AB plus BC. Just if you solve AB plus BC, AB, now cross multiply, AB plus BC is equal to 1500 minus root 3 into root 3. 1500 into root 3. So AB equal to 1500 minus root 15 root 3 minus so 1500 minus 1500 root 3 minus 1500. So root 3 is common. So you can take AB equal to 1500 in root 3 minus 1. So you can take root 3 common here. So if you solve, you will get 1500 equal into 1.732 minus 1. You get approximately 1095 meters. Therefore, the distance between two is 1095 meters. So next question, very simple question. This is MCQs. Let us go. Yes. So this first question says that a ladder 14-meter long. So length of ladder is 14 meters long, rests against the wall. So foot of ladder is 7 meters, then angle of elevation. You guys did it, right? Elevation we guys learned, right? So the correct answer would be 45 degrees. So let us go to the next thing. A triangle ABC. There's a triangle ABC. BC, and then angle A is 30 and angle B is 90 degrees. So 30, 90 and AC is 8 centimeters. Then area 8 into this. So you will get this is actually not in syllabus. So just for your information, I have given this sum. So the correct answer is 8 root 3. And the bonus question. Sorry. Okay, and question. Let us do this question. Let us solve. It says from a top of a cliff. So there is one cliff here. From the top of a cliff, the angle of depression of top and bottom of a tower. So, or this thing we'll do 2017 paper. So the angle of depression of two ships A and B observed from a top of lighthouse are the lighthouse is 60 meters high. So it says the angle of depression of two ships A and B as observed from the top of a lighthouse 60 meters high and are 60 degrees and 45 degrees respectively. So they have given the length of height of lighthouse to be 60 meters and angle of depressions of two ships A and B as 45 and 60 respectively. So now he says that there are two ships on the opposite sides of the lighthouse. Find the distance between two ships. Give your answer correct to nearest whole number. In all cases, we did angle of depression. We'll give you 1 minute to solve this question. Solve and let the answer. Then comment the answer in the comment box below. Wait. So let us solve together. Now, in all cases, we have to assume let PQ be the lighthouse. Lighthouse, which and PQ height they have given us 60 meters. Now we have to consider triangle PAQ, and we have to use tan 60 equal to P perpendicular by base root 3 equal to 60 divided by base equal to 60 divided by root 3. Now to solve this further, you just cannot do 60 by 1.732. It will become wrong. So what you do is you have to rationalize numerator and denominators. So multiply and divide by root 3. So 60 into root 3 divided by 60 into root 3 divided by 3. Root 3 times root 3 is 3. So 60 into 1.732 divided by, no, 60 divides 3 ones are 3, 2s are 6, 0. So 20 root 3, my first equation. One minute, guys, just PBQ tan 45 tan 45 equal to perpendicular by base. So tan 45 is 160 by base. So we learned perpendicular was 60 meters. So base equal to 60 meters. Our second equation. So now where is let me draw this diagram for you. This is 45 degrees and this is 60 degrees. So 60 and 45. These two meet at right angles at Q, B, P, and A. I figured it. Right? Yeah, tan 45, we figured out QB value to be 60 meters and lighthouse is 60 meters too. So we have to find in this will be easier. So AB, where is AB is equal, AB is nothing but AB is equal to AQ plus QB. They have given QB values, so 60 plus AQ. AQ we got it as 20 root 3, remember? 20 root 3 is equal to AB. 20 into 1.732. 20 into 1.732 plus 6, another 60 gives 94.64 meters. You cannot leave the answer just like that. You have to convert this answer to the nearest possible meter. So this will give 95 meters. So I hope you have understood heights and distances much clearer and easier now. So let us summarize what we have learned. So we have learned to apply trigonometry to solve the problems. Learn to define angle of elevation, angle of depression, and angle line of sight. So I hope this video has made it clear about heights and distances and its applications. So, until we meet next time, take care, God bless you, and all the best for the exams. And if you have not subscribed to my channel, please do, and please press the like button and comment below. So, bye for now.